So we are live. I always start with this lesson, lesson 1, what is physics? I started teaching physics in 2003. I have a mathematics degree. I have a Bachelor of Science in Mathematics. And my first few years, I started teaching in 1997. This is year 20 for me. I taught math. And then in 2003, when I started teaching physics, my mom said to me, you know, Kelvin, I know what math is. It's like plus signs and numbers, and I got that. What's physics? What is physics? I'm going to give you the definition that my physics prof gave me back in the day. My physics prof said that physics was the science of measurement. Now that's a pretty generous definition because, Maddie, it means if you're measuring something, you're doing physics, which really means he was taking all of science and calling it physics, which was a little arrogant, but we'll take that. But it leads to another question. Okay, if it's the science of measurement, what do we measure? 3 main things. We measure length in, what are the standard SI units for length? Meters. We measure time. What are the standard SI units for time? Seconds. Oh, by the way, you should clue in, I'll rarely write out whole words. I tend to abbreviate. See how I did that? I breathed the, no? Over your head? Sorry, Dom. By the way, you wrote Dom on here. If you fill in your personal information on the web, put Dom for you, and I'll change it to that. The last thing we measure is mass. Standard units for mass? It should be grams, really, but when they defined the gram, it's too small. It's the only standard unit that has a little metric prefix, a kilo, in front of it. It doesn't quite fit in. In fact, we call this the SI system. It's French System International. You can sort of think of it as the metric system, but it's not really, but they overlap an awful lot. There are 7 quantities in science that are defined. Everything else is based on these 7 quantities. The first 3 I've already given you: length in meters, time in seconds, and mass kilograms. Another quantity that's defined: current. Anyone know the units for current? Yeah? Amps. Volts, someone said volts. Volts are defined in terms of amps, as are ohms, as are farads, as are, everything else is defined in terms of amps. Amps, symbol, capital A. Temperature. What is the SI units for temperature? Degrees what? There are different scales. What's the standard SI temperature scale? I'll give you a hint. It's my favorite unit. Kelvin. My first name is Kelvin. I am an SI unit. It's degrees, lowercase k, which is degrees Kelvin. When Google first came out, around 1999 or 2000, it was great. If you did a search for my first name, Kelvin, the first page that came up had in huge letters that took up the whole screen, Kelvin is God. Then Google changed their algorithm. Stupid Google. Amount of a substance. You'll learn this one in Chemistry 11. Mr. Perugia has a little mole. That's defined. Okay. It's not measured. A meter is defined. It's not actually measured. The last one is light intensity. This is a neat unit because as soon as I tell you what it is, you'll know exactly how big one is. If I say to you, how big is a second, unless you've listen to time enough to know that's about a second. You have no way of knowing just from the name that that's a second. Light is measured in, anybody know? Candles. And you now know instantly how big one candle is. Yeah, that big. Exactly what you're thinking of. Abbreviation CA. If you want to, you can draw a little kind of a line right there. The top three are physics 11. Amps will be used in physics 12. We're not going to look at temperature or light intensity, and mole is chemistry. But anything else that you've heard in science is defined based on these 7. Easy way to compare temperature units. If you're talking the Fahrenheit scale that the US uses, 0 degrees is really cold outside, 100 degrees is really hot outside. Celsius, 0 degrees is fairly cold outside, 100 degrees, you're dead. Degrees Kelvin, 0 degrees, you're dead. 100 degrees, you're still dead. There's your difference in temperatures. You don't need to know that. That's just hashtag nerd trivia. Turn the page. In addition to the base units, the SI system uses a prefix system to allow for the expression of really big and really small numbers without having to write all the zeros. Prefixes can be placed in front, and they represent a multiplying factor. For example, 2.5 kilogram, kilo can be replaced with 10 to the third or 1,000. It's 2.5 grams times 1,000. It's 2,500 grams. So the prefix kilo means multiply by 1,000. I'll almost never write them out longhand. Have I mentioned already that I tend to abbreviate 10 to the third? That's much less writing. So we're going to fill in this chart. We're going to start in the very middle right here where it says base unit. This is where you would have just plain old meters or liters. Whenever I do a lowercase l, I'll always write it in cursive. Why would I never write a lowercase l like that? What will that look like in math or in physics? It's going to look like a 1. We can avoid the confusion. So you'll see I always write a lowercase l like that just to make sure. Other base units, grams, joules, amps, newtons, whatever. Those get multiplied by a 1. Does multiplying by 1 actually change anything at all, Morgan? So we never bothered doing that. If you want it as a power of 10, 10 to the 0 is a 1. Again, we skip that. But for what it's worth, okay. We're going to work our way upwards and get bigger. Deci. This is all, I believe, on your green sheet. I think there is a chart of all of these, so you do not need to memorize any of these. We're going to fill this chart in our notes once, just so we know where they are, but then you'll know that you can look them up. What's the abbreviation letter for deci? It's a D, lowercase, uppercase, or just lowercase d, and that's it? And deci, I'm pretty sure, 10 to the 1, yes? So a deciliter is 10 liters. 5 deciliters is 50 liters. I don't know whether it's pronounced, oh no, you know what, it is pronounced deci. I was going to take that back. Then there's centi. Is this right? No, it's not 10 to the 1. 10 to the negative 1. Is that what you guys are looking at? Because we're getting smaller going this way. That's right. I started with smaller on top and then got bigger. 10 to the negative 1. You're dividing by 10. 10 to the minus 1. By the way, I never make mistakes, is the dumb joke that I always say. I am the king of making dumb mistakes. I'm buying candies this weekend. Anytime you catch me in a mistake, get your hand up, point it out, you get a candy. So you should have pointed out my mistake right there. Centi, lowercase c, yes? The most common one that you're familiar with is probably centimeters, which is 1/100th of a meter. 10 to the negative 2. It's the same as dividing by 100, but rather than having some dividing and some timesing, let's just make them all timesing. 10 to the negative 2. Milli, this is where we already get tricky, because the symbol for milli is lowercase m, the symbol for meter is lowercase m. If the m is in front of another letter, it's milli. If the m is sitting by itself or at the end of another letter, it's meters. Our English alphabet, you're going to find very quickly, we run out of letters. In particular, capital N is used for 3 different things in physics, and it's just all based on context. 10 to the negative 3, yes? So a millisecond is 1/1000th of a second. 1,000 milliseconds, 1 second. Micro. Well, we can't use the letter M for micro because we just used it for milli. So what the heck can we do for micro? We pull out a Greek letter M, called a mu. It's like this. What does a Greek cow say? Mew. What does a Greek cat say? Mew. There's all sorts of dumb jokes to go along with this. This is actually where our English letter M came from. So it sort of looks like a lowercase u with a long tail. Sort of. Like that. And it's 10 to the negative 6. In Physics 12, you'll end up memorizing that one out of laziness. When we start to look at electricity, we typically look at microcoulombs, and every time you see that little mu, you'll get tired of looking it up and remember, it's 10 to the negative 6. You'll memorize that one. You don't have to memorize it. Physics 11. Nano. 6 years ago, I stopped here because 6 or 7 years ago, we were at the nanotechnology stage. Lowercase n and 10 to the negative 9, yes? I've had to add to this a little bit. Pico, I think, is a lowercase p. Yeah? No? Yes? I'm going from memory here, and I don't memorize this, so if I'm wrong, let me know. And now we start to go up by powers of 3, so it's going to be 10 to the negative 12. Yes, I think. Okay. Nano, you're molecule sized. Pico, you're atom-ish sized. Smaller than that, you're really small. Femto is a lowercase f. I will later on show you a video of a femto camera. It's a camera that can take a photo so quickly in a femtosecond that you can actually physically see a beam of light moving across the room. I swear to you, and I'll show you that later. 10 to the negative 15, yes? And then last year, I added this last one because we're starting to approach some elements of technology. Atto, lowercase a. Now you're talking, actually, you're starting to approach the size of subatomic particles. And at this point, we don't know if you can get smaller than subatomic particles. So this may be as far as this chart can go in the universe. Who knows? 10 to the negative 18, yeah? I think on your tests or quizzes, because I haven't rewritten them lately, I doubt I go past nano, but nerds always want to know, so okay. Let's get bigger. Deca, I never use deca. It's D-A? All lowercase? Yeah. It's 10 to the 1. The reason is, I would never say 5 decagrams. I'd say 50 grams, and it's less writing to write the 50 than it is to write the, it's kind of a useless metric prefix. Prefixes are meant to make things shorter and less writing. Deca's right around, well, it's easier to write it up. So that one I always have to remember, never use it. Hecto was another one I never use. Is it a lowercase h? You guys see on the chart what we're talking about, right? On the green sheet. No, on the green sheet, on the back page. It's all there. You guys are looking so... Oh, yeah, Sean, I'm telling you, you don't need to memorize this. It's all in the back of the... Yes? Right? Hecto, lowercase h? This is where we're getting the numbers. None of us are memorizing this crap. Why would we? 10 to the 2? Kilo is really the first one that I start to use consistently. And this is one you're familiar with as well because you're getting your licenses. Kilometers. 1,000 meters, 1 kilometer. 10 to the 3. Mega. 15 years ago, 20 years ago, I would have stopped at mega. My first ever hard drive, I swear to you, was 8 megabytes. And I remember thinking, how will I ever fill that up? 8 megs, that's huge. Who could ever have 8 megs of data? Wow! Uppercase M, yes? So you see we have 3 prefixes that begin with M. We use an uppercase M, a lowercase m, and what does a Greek cow say? Mew. 10 to the 6th? A million. Mega's a million. That's why there's that lottery, Mega Millions or whatever. At least they got the math right. Mega's a million. About 7 or 8 years ago, giga became the thing. Gigs, we call it for short. Your phones have this many gigs of storage. 10 to the 9th, yes? Gig is a billion. Then about 5 years ago, I bought my first terabyte drive. Capital T. 10 to the 12th. 3 or 4 years ago, Google was claiming that their servers could actually handle petabytes of data. So that was where I first saw peta used like in industry as a number. It's capital P, yes? And it's 10 to the 15th. Yeah? I'm hearing as I read with the whole quantum computing perhaps coming in the future. EXA may be on the horizon. I'm not sure. Quantum computers are weird. Anything in quantum physics is weird. I think Richard Feynman said anybody who claims to understand quantum physics hasn't read it because it's just weird. But it works. Capital E? Yep. And that's 10 to the... I'm sure you can go further. I don't know what they are. I'll add them once our level of technology has advanced enough that they show up. Going this way, I don't know that we can physically get much smaller than that. I haven't yet found anything in the universe that has a use that's that small or smaller. Any base unit can be used with a prefix. For example, 1 kilogram, replace the kilo with a 10 to the 3rd or 1,000. 1 kilometer, 1 kilosecond. 100 centimeters, 1 meter. 1 liter, 100 centiliters. 1 gram, 100 centigrams. I'm going to teach you a simple method to convert any unit to any other unit. There's going to be one that we do so often, we'll memorize a shortcut, because that's the only reason you should memorize something, because it's a good shortcut and using it all the time, but we won't memorize it just for the sake of memorizing it. Put your pencils down, look up.